Yogaha Karmasu Kaushalam.
Good morning, everyone. My name is Dr. Kapil Kumar, Associate Professor, Department of Biochemistry and Forensic Science, Gujarat University, Ahmedabad. Today's topic is application of physics in forensic science. The word forensic science is derived from the Latin word forensis, which means before the forum or a court. We can say that forensic science is the application of scientific principles in criminal investigations or legal investigations. Forensic science is also known as science of comparison because most of the time in investigations we compare the evidences or the physical evidences recovered from the crime scene with the suspect or with the victim. So there is a correlation being established between these two or these three in forensic science. So that's why it is also known as science of comparison. Violation of law of any kind of law is known as or included as crime. Laws can differ in nature. Laws can be legal laws like laws related to the bodily crimes, properties, or laws related to the civil matters. So if any violation of even the laws related with environmental sciences can be included in this, and whenever there is a violation of these laws, a crime, we said a crime is being committed. When a systematic and a scientific analysis is done to solve these crimes or to know the root cause of these crimes, uh, such type of investigation or work is known as forensic investigation. So we can say that a forensic investigation is a scientific process of obtaining or determining the root cause of a crime, where we prove that whether a crime has been committed or not, if committed, who is responsible for it, and what are the evidences or the supporting evidences for these findings. So these are the factors which a forensic scientist should determine while investigating any kind of crime. Application of laws and principles of physical sciences in solving criminal cases is known as forensic physics. Forensic physics may include different aspects of physical sciences, which can start with laws of motion, which generally covers in engineering studies as well as in courses of physics, dynamics, or kinematics. General physics in forensic science involves electrical, mechanical, chemical, and laboratory analysis. It may include mathematical formulations based on recognized principles of fundamental physics. Fundamental laws of physics like conservation laws of momentum, collision, Newton laws of motions are having a great and vital application in reconstruction of crime scenes. All the fundamental laws of physics are very much useful to analyze the evidence as well as draw any conclusion. There are different types of physical evidences which are being examined in forensic physics. In this category, evidences or physical evidences like paint is recovered in cases of hit and run, burglary, or in cases of theft are to be examined. Likewise, glass as an evidence is recovered in cases of road accidents, theft, in cases of violence, even in cases of like murder or in homicide cases also, a glass is recovered as an evidence. So in that case, we need to examine the glass or physical properties of the glass, many of the times the chemical properties of the glass, and to compare whether the glass pieces or fragments come from the same source or not. So they are the major questions which are being asked for glass examination. Another type of physical evidence which is being examined in physics is soil. Soil is one of the most important evidence for correlating the crime scene with the suspect or crime scene with the victim. The comparison of the soil obtained from the shoe or sole of the suspect or victim can be compared with the suspected crime scene site, and a correlation or match can be established that okay, both these soil samples come from the same source, and a relation can be established between crime scene and the suspect or victim. Likewise, fiber as an evidence is recovered in cases like murder, or in cases of theft where some particles or piece of a cloth is being left on the crime scene knowingly or unknowingly. So fibers can be in both the categories. They can be natural fibers like wool, cotton, and all these things, or fibers can be artificial, that is the nylon or synthetic fibers. So any kind of fibers can be recovered from the crime scene. Examination of physical evidences like metal pieces, threads, tool marks, ropes, and obliterated marks are also being included in physical examinations. Evidences like metal pieces are recovered in the cases of theft or in cases of assault, where the metal pieces or the particles may be recovered from the fence where someone has forcibly tried to enter in the fence, or metal pieces can be recovered in cases of tool marks, that is the broken tools are found on the crime scene. Many of the times these metals or wires can be recovered in cases where strangulation or hanging is done with uh, these wires or these threads. Thread examination is important in cases of hanging, where we need to know the type of knot being used, strength of the rope or thread, strength of the fibers, okay, whether the fibers are cut or they are broken. Okay, so all these things are very important for forensic investigations, because a wire is, whether a wire was cut, deliberately cut, or it was broken either by the quality or the force implied on it. So both the two things can give a lot of information about the crime. Like suppose a brake wire, there are evidences that a brake wire has been cut. In that case, a deliberate attempt of murder can be charged on the person uh, who has tried to cut that brake wires. Okay, so that is such small investigations or small findings or physical findings can solve many cases and can help in investigations. Tool marks examinations is done in cases of, especially in cases of burglary or robbery, where the culprit or the suspect leaves the marks of the tools which are being used to break the safe or the doors, many of the times the windows, for forcible entries. So these tool marks are particular, or we can say it can be individualized to a particular tool. So recovery of that tool from that person and comparing that tool marks can let us know whether what kind of tool was used in the crime, and if the same tool is recovered from the suspect, we can relate that this is the person who has used it. Obliterated marks can be seen in cases of uh, theft, where identification marks like number plates or chassis numbers are being removed or obliterated to hide the identity of the vehicles. In forensic physics, the evidences recovered from the crime scene are being examined on various examined for various properties in physics division. Evidences like soil is being examined for density of the soil, or or its components which are present in the soil for comparison. Usually in this case, the density gradient is being prepared for various kinds of soils, and they are being compared with each other. Likewise, the properties like resistivity is being measured for electronic evidences which are being recovered from the crime scene. Elasticity of the ropes, wires, or any kind of fibers are being measured for either comparing those fiber materials or knowing its properties. Properties like refractive indexes are being measured for evidences like glass. Many of the times refractive index of like materials or some shiny materials can also be used in this categories. Examination of temperature, usually in cases of arson, at what temperature a metal might have been melted. Okay, properties of various substances, properties of break or the force applied or the friction. So what temperature is being reached with that friction force. So such type of examinations can help in cases of in forensic engineering. Uh, Properties like luminescence and all are being examined for fluorescent substances or substances which gives the fluorescence, and various components of the physical evidences are also being examined in this category in forensic physics division. There are various types of crimes in which forensic physics division can help in investigations and analyzing the exhibits. In this category, in maximum number of cases are being recovered in the cases of accidents. It can be vehicular accidents, it can be civil accidents like construction failures or collapse of the bridge. It can be fire accidents where fire has broken in some places. So evidences recovered in cases of these accidents are being examined in physics divisions. In another type of cases where firearms and bullets are being used, especially in cases of shootings, murders, or in suicide cases, the comparison of firearms projectile motions are being examined to know the velocity of the bullet, from which direction the bullet was being fired, what was the speed, height, angle, trajectory of the bullet. So all these things are being examined or measured in cases of firearms or bullet profiling. Uh, in cases where like glass penetration of speedy stone, so what was the velocity of the stone, or it may be any bullet. So even in cases like 2 or 3 bullets are being fired on a person, so in that case examination of windshield glass will let us know, okay, which bullet was fired first and which was fired second. So examination of glass and glass patterns can determine the sequence of fires as well as the velocities with which the stone or the bullet are being pelted. uh, Another, the most important is the bullet and tool cases are being examined, where we correlate the bullet with the fired weapon, or we can say we correlate the bullet marks with the barrel of the firearm. This is being covered in details in the later section of this presentation. In cases of fire, arson, and in explosive investigations also, the physics is being used. In fire cases, examination of accelerants, examination of the highest temperature reached, point of fire where the fire is being initiated. Okay. Uh, in cases of like whether this spark has taken place or there is a deliberate fire. So all these investigations are being done in physics divisions. Burning of wire, burning of electronic evidences or electronic uh, machines or electronic appliances, all these things can be examined or being investigated in forensic physics. Then identification of materials, like identification of fake jewelries, identification of certain substances which are being smuggled as jewelry or as a fake uh, instruments or metals, they can also be examined or they are being examined in forensic physics. Then there is like a branch of physics, we can say forensic physics, which also deals with imagery and photography also, where we use software based imagings to obtain the evidences or evidences for illustrating a crime or reconstructing a crime scene. Methods of facial reconstructions can also help in investigations. So many of the times they are also being done, like in superimposition is one of the method where the skull is being superimposed on the photographs of the person to correlate the skull and the photographs. So that is being carried out in uh, photography or in physics division. Forensic engineering and building material labs analyze why things fall. In physical science and engineering, while manufacturing faulty toasters that electrocute people, or to buildings over the bridges and river bridges that collapse, and in many people die due to incident of faulty constructions or faulty manufacturings. So all these examinations are being carried out in physics divisions. Forensic engineering, which is a part of forensic physics division, is also useful to reconstruct road accidents, electric fires, etc. On the basis of tire or skid marks, damage on the collided vehicles, surrounding scenarios, and physical evidences by using the law of physics may easily determine the path, the direction, the speed, and the type of collision that occurs or what might happen in such situations. So these findings will help in the cause of accidents or cause of that crime, whether it was deliberate or it was being like accidental. So such type of investigations or the findings will help in resolving or giving conclusive evidences in these cases. The findings of examination of exhibits obtained from the crime scene are further used to correlate the suspect with the crime scene. Many of the times, there is a need to reconstruct the crime scene for determining the sequence of events which has occurred and the circumstances in which the evidences are being left on the crime scene. So in these cases, especially in the cases of train accidents, suicides or homicides, reconstruction of a crime scene is very helpful, where like reconstructions of the fall of the dead bodies are from a height are being done to know the facts, that is the distance from which it was like it will fall, or the position, exact position from where it will fall. uh, Reconstruction of crime scene, especially in cases of accidents, the skid marks analysis or skid marks gives a vital information, like what could be the speed of the vehicle, in which direction the vehicle was moving, what was the like speed when brakes were applied, whether brakes are applied or not, that is also in question. Okay, and whether the vehicle drifted after brake. So all these things can be determined by skid mark examinations. The yaw mark, that is the drifting of the vehicle, when a sudden brake is applied. Okay, so in that case the vehicle changes the direction either towards left or right depending on where the steering was moved. Okay, so there will be a drift marks, or there will be like a prominent skid marks which are known as yaw marks, and this analysis of yaw marks will let us know whether the driver tried to avoid the accident, or whether an attempt was made to like avoid the accident or not. Similarly, in dead body falls from height may be calculated on the basis of fundamental physics. Material science is also having a wide range of applications in forensic science, uh, where it is used for interaction of radiations with matter like X-rays and gamma rays. Using the phenomena of X-rays, which is based on non-destructive techniques like XRD, XRF, EDXRF, and uh, SEM, that is scanning electron microscopes, become useful for instrument. Those are widely used in forensic science laboratories. As a result, forensic material science may become a field of its own in the future. In the last 2 decades, material science has a vital role in analysis of the minute evidences which are being collected from the crime scene, uh, and with the help of analytical techniques. The electronics is purely a subject of physics. Analog electronics is useful for cases belonging to fire and arson. Sometimes explosive materials, or in cases of explosions, analysis of electronic evidences, especially in cases of IEDs, that is improvised explosive devices, where a clock, a mobile, or a circuit is being used to trigger the explosions, can help in the investigations. The electronic devices used to commit crimes come in these categories, especially in cases of analog advanced physics, comes with subcategories as digital electronics, computer forensics, and mobile forensics. This entire examination of these evidences is further classified in the sub branches, where digital electronics deals with the electronic evidences, computer forensic deals with the crimes committed by using computer forensics, and in mobile forensics we deal with the crimes committed with the help of mobile devices. So in this case, there are cyber crimes, or cyber forensic crimes that can be occurred from mobiles. But in few cases where mobiles, it has been seen that mobiles are being used to trigger the explosions. Mobiles are used for spying purposes. Mobile are being used to track the persons or the positions of the persons in uh, real scenario or in live cases. So such type of analysis or crimes can help us uh, in many ways, and can solve the cases in a better manner. The electronic evidences recovered from the crime scene comes under Indian Evidence Act 1872. The examination of these devices, working of these devices, or any manipulation or tampering of these devices can also be established, and that is taken as an evidence or exhibit in cases or investigations. So devices like cameras, mobile phones, even pen drives, tablet, smartwatches, all these things, any electronic device, it can be even a calculator or a simple device, can also be included as electronic evidence in this category. Forensic examination of audios and videos recovered in cases are also done in forensic physics divisions. Audio evidences can be recovered in cases of kidnapping or in cases of abduction. Audio evidences or video evidences can also be recovered in cases of briberies or cases related to anti-corruption bureau. So in that case, we need to establish the voice, whether a particular voice belongs to a person or not, or whose wife is. So vice versa examination is also there. So in this voice examination, or we call it as audio video processing, the very first step of analysis is to simply listen to the listen or view the recorded footage. Okay, the examiner will then begin to locate the area of interest to be enhanced and examine in closer detail using specialized devices and softwares. So before processing audio and video evidences, a working copy of your evidence may be created. Actually, this working copy actually ensures that the original evidence is always available in its unaltered state. In addition, the original will be available for comparison um, process as a or processed copy. Okay, so the real evidences will always remain for examination. So whereas the other findings or investigations can be done on the recorded copies. For this audio and video processing, there are various softwares available with forensic experts in forensic divisions, forensic physics divisions, where we use or we obtain the spectrograms, the parameters, that is the wave natures, and different parameters like frequency, wavelength, amplitude, and like wave fronts, and all these parameters, the waves are being examined or voice samples are being examined to establish the identity of the person. One of the important branch of forensic uh, science is forensic ballistics. Basically, forensic ballistics is a branch of applied physics where we use principles and phenomena or applied physics to investigate the crimes where a firearm, that is a gun or a weapon, is being used to commit a crime, especially in cases of homicides or suicides. But in this category, in many of the cases, accidental discharge of the fire is also seen. So in that case also we need to establish the uh, suspect with the victim or the process of events which has occurred on the crime scene. So this ballistic evidence examination is covered in the later half of this lecture. Ballistics is a branch of uh, forensic science which deals with the shooting cases, and it is also a branch of applied physics which deals with motion of projectiles and conditions governing that motions. Broadly, ballistics can be divided into three categories. That is internal ballistics. Internal ballistics deals with the phenomena which occur inside a weapon. So whatever studies we make, what was the cartridge, what ammunition was used, what was the structure of the firearm, what was the action mechanism of the firearm, how the projectile works, how the projectile behaves in the barrel. Okay, so all these phenomena are studied under internal ballistics. External ballistics deals with the phenomena or the studies which are done when a projectile leaves the muzzle end of the barrel. That means when a projectile comes out of the barrel and before striking the target. So target can be anything. It can be human body or a non-living thing. So whatever phenomena which is occurring during the flight of the bullet from muzzle end to the target is studied in this topic. So that's why it is known as external ballistics or exterior ballistics. The third is the terminal ballistics. Terminal ballistics is the study of phenomena and the evidences or incidences occurring when a projectile strikes a target. Now, target can be a living object or a non-living. When a target is a living body or living object or body, so then we call it as wound ballistics. And if the target is a non-living object, then we call it as uh, terminal ballistics. Okay, so in both the types of wound and terminal ballistics, we study the different phenomena. Like in wound ballistics, we study the injury patterns, what kind of injury is made by the bullet, okay, what was the angle from which it was fired. Okay, so that we will see in later stage of this presentation, the various kinds of wounds or the phenomena which occur in terminal ballistics. So let us start with the definition of firearms. In short, we usually know firearms by the name guns or weapons. So firearm is defined under Indian Arms Act and includes many things. The firearm in the definition, if you see, it includes artilleries, hand grenades, riot pistols, weapons. Even the accessories for making these firearms is included in these definitions. Or part of any machinery or manufacturing of these firearms, they are also included in the definition of firearms. But as far as design is concerned, so firearm means any description, design or adapted to discharge any projectile by action of any explosion. So this is very important that a firearm should be able to discharge a projectile by any explosion or any form of energy. So that explosion or form of energy is important to like define a firearm for the discharge of projectiles. The firearms can be classified into various categories depending on the characteristics which they produce. In this category, the very first is on the basis of bore characteristics. Bore is the internal surface of the barrel. So on those bore characteristics, the firearms can be divided into smooth bore firearms and rifled bore firearms. Smooth bore firearms includes shotguns and shotguns, and in rifled bore includes the rifles like pistols, revolvers, or the service rifles like AK-47, INSAS, SLR. On the basis of loading characteristics, the way the firearm is loaded, so they in that firearms can be divided into two parts, that is muzzle loaders and the breech loaders. In muzzle loaders, the barrel is loaded from the front part of the weapon, that is called the muzzle end of the barrel. Like if you see all the ancient weapons like matchlock guns, beadlock guns, flintlocks, so all those guns were muzzle loaders in nature. The second is on the loading characteristics. Second type of gun is the breech loaders. In breech loaders, the gun is loaded from the breech end of the barrel, that is from the back side of the barrel. Okay, so all the modern firearms, AK-47, INSAS, and even the revolver pistols, they all are breech loaders in nature. Another category of classification is action mechanism. On the basis of action mechanism, the weapons can be manual action, semi-automatic, and automatic. In manual weapons, all the process, that is loading, extraction, ejection, and firing, all these processes are done manually. Whereas in semi-automatic weapons, loading, extraction, ejection is done automatically, but firing is done manually. Whereas in fully automatic weapons, all these processes, that is loading, extraction, ejection, and firing, All these processes are done automatically by the gun itself. So one initiated or triggered. So that's why it is called as fully automatic weapons. Next is the classification of firearms on the basis of handling characteristics, like how we handle the firearms. So it basically depends on the grip, like while firing, what should be the position of the firearm. So in this category, the very first thing is handguns. The example is like revolvers and pistols. Okay, they are also known as small arms, which are like handheld firearms. Second is the shoulder guns. For the fire, we need a shoulder support for them, or we can call it as long guns. Okay, so that includes .303 and all, basically all rifles, the big rifles, they all are included in this category. Next is the mounted weapons. Mounted weapons are large weapons or a higher caliber weapons where we need to mount the weapon. It is difficult to hold that weapon in hand or shoulders. So we need basically stand to mount it. So we can have a bipod stand or a tripod stand to mount that weapon. The examples of this mounted firearms is LMG, light machine gun, or MMG, mega machine gun. So these are the big weapons or big caliber guns which are being used. As we saw in the classification of firearms, on the bore characteristics, firearms can be classified into two categories, that is smoothbore firearms and rifled bore firearms. The smoothbore firearms, the inside the barrel from inside or the cylinder is smooth. Okay, whenever we cut a cross section of that barrel, we always obtain a circular cross section in it. Another type of barrel is the rifled bore firearms. Rifled bore firearms are the one of the best choice for modern firearms. Majority of modern firearms are with this rifled bore inside them. So what is rifling? Rifling is the cutting of grooves, number of grooves in the barrel. Okay, these grooves are parallel in nature, but with a twist. That is, they are helix in nature inside the barrel, as you can see from the figure as shown here in the slide. Okay, so these in this rifling, the raised portion between the grooves is known as lands, and the depression is known as grooves. So we can define rifling as presence of lands and grooves inside a barrel uh, in a twist or in a helix structure is rifling. Now, second question arises is why there is a need to have a rifled bore? Or why can't we use the smooth bore? Or what are the advantages obtained by a rifled bore? By doing a rifling, okay, rifling gives a gyratory motion to the uh, projectile or the bullet. Okay, gyratory motion is spinning of the bullet on its own axis. So when this bullet goes out of the barrel or the muzzle end, it continues spinning in that motion. Okay, and this gyratory motion or spinning motion has two main important effects on the projectile. First is this gyratory motion or spinning of the projectile gives the stability to the bullet, or the stability to the bullet in the flight whenever it is there in the air. The second is it decreases the air resistance. Because of the decreased air resistance, the velocity of the bullet increases and the range of the bullet increases. So by one can conclude that by rifling inside the barrel, we can have increased velocity of the projectile, increased range of the projectile, as well as the projectile is more stable, which gives a higher accuracy and aiming power to the projectiles. So that's why the rifling is so common, and one of the major boom we can say in the invention of the firearms or weaponology, and that gave rise to very high projectiles being fired from the rifles with high precisions. The number of lands and grooves inside the rifling varies with various types of manufacturers. Like different lands or grooves can be there in the barrel. Usually this number ranges between 2 to 16 lands or grooves inside the barrel. In case of rifled firearms, the caliber of the firearm, that is the diameter of the barrel, is measured between distance between the two lands or distance between the two groups. Okay, so basically we measure the shortest distance, that is lands, but in opposite direction, if it is a groove, then also we consider that as a land and we take the measurements. All the major rifled firearms, that's why, are nomenclatured on the basis of their calibers. Like if it is when we call it as .303 rifle, that means the caliber of the rifle is .303. Likewise, when we call it as 7.62 SLR, that is self-loading rifle SLR. So this 7.62 is the caliber of the weapon. Likewise, 5.56 INSAS. INSAS stands for Infantry Small Arms Systems. So 5.56 is the caliber of the weapon. The spiral formation of the rifles, or the spiral formation of the grooves, is known as the twist of the firearm. So twist of the firearm is obtained while during the manufacturing, when we cut the barrel or we cut the grooves inside the barrel or the cutter is moved in clockwise or either in anti-clockwise direction, depending on the different manufacturers. Okay, so that turn, actually during the cutting of the grooves, gives this spiral motion inside this barrel. So this turning of the barrel or the groove is called the twist of the barrel, whereas the angle uh, of the turning, that angle in which the turn is made, is known as pitch of the firearm. Now, this pitch of the firearm can also be defined in another manner, that is the length in which the twist completes one single turn. Okay, so that is also known as pitch of the firearm. Like in .303 rifle, the pitch is 1 turn, that is 1 turn, a complete turn is made in 10 inches. So we call it as the pitch is 10 inches. Where likewise in 7.62 SLR, 1 turn is completed in 30.5 centimeters. So twist is responsible for the spinning of the bullet, how the bullet will spin, or how much a bullet should spin. More the twist, more there is a spinning motion of the bullet. So here illustrated here is the diagram of a rifled cartridge. Why the rifle cartridge is important? Because all modern firearms are having rifling in their barrel. So there is a specific kind of cartridge being made which is structurally different from the shotgun cartridges. In rifle cartridges, it can be divided into 4 major categories. One is the body of the cartridge, that is the construction of the body. The body of the cartridge is usually made up of brass in rifled cartridge, brass or any alloy of brass. The second part is the primers. So primers in the cartridge are the initiating explosives, okay, which initiate a firearm. Usually it is present on the lower portion of the cartridge, which is known as percussion cap. So these percussion cap contains the primary explosives or primers. These primary explosives are very sensitive to shock. So once a small strike of a firing pin can initiate the explosion in these primers. So they are in very small quantity in a cartridge. Okay, so when a firing pin strikes this percussion cap, that is base of the cartridge, okay, uh, these primers get ignited. Second part of the cartridge is the explosive charge, which is in the body of the firearm. So primers, chemical composition of the primers can be mercury fulminate, lead azide, lead stepnates. Whereas this explosive charge above is known as the propellant. So this propellant is the actually or the main charge is responsible for developing the gases or pressure inside the cartridge when it is being fired. So propellants, the very first propellant which was discovered was gunpowder or black powder somewhere in 11th century. Then gave rise to many other new kind of powders like smokeless powders, semi-smokeless powders. Okay, today we have like prototypes are available where even RDX is used as propellant in the cartridge. So as I discussed, these propellants are responsible for developing the gases or the pressure inside the cartridge. Third is the projectile, that is the bullet, the nose which is just coming out can be seen here, that is known as the bullet. So bullet is the projectile in the rifled cartridges. It's a single projectile attached with the body of the cartridge. Now how it works is that a firing pin strikes the base of the cartridge where primers burn. These primary composition subsequently burns the propellant charge. On burning of this propellant charge, then a large amount of gas and gases is evolved, okay, which further exerts a pressure towards the projectile. And projectile, by leaving its packing pressure, starts moving in the barrel and then comes out of the barrel. That is how the firearm is being fired. In the shape of the cartridge, there are like various aspects of explosions or lot of studies has been done on propellant charges, what kind of propellant charges should be used in what type of weapons. But here I would like to discuss the bullet as a whole. The shape of the bullet is a very important phenomena in forensic physics, or we can say in forensic ballistics, because shape of the bullet will determine its aerodynamic position or its aerodynamic characteristics in the flight when it is in the air. So shape of the bullet is very important. The bullets can vary in different shapes depending on the purpose in which they are being used. So illustrated here are the bullets like number one, the flat nose bullet, usually used to damage the target, especially in cases when we want to damage the wall or some kind of door or locks. So in that case we use a flat nose bullets. Then there is a blunt nose bullet, cylindroconidal bullet, which is the most standard kind of bullet. Both-tailed bullet is being used in majority of rifles to reduce the air resistance and to increase the range and velocity of the uh, bullet. Next is the streamline bullet. Streamline bullet, though the shape of the bullet looks like it will be very aerodynamic in nature, but practically it has been seen that it is not that effective um, in practical aspects as compared to boat-tailed or cylindroconidal bullets. So streamlined bullets are like obsoleted nowadays. They are no more used in the firearms. So these are the sequence of events which we have already discussed, but still we can have a quick recap of it. That when a firing pin strikes or first hits the primers, the primary detonates primers detonate. They further deflagrate the powders, propellant charge in the cartridge, which further increases the pressure. Bullet forced from the casing into the barrel. The rifling imparts spinning as bullet travels through the barrel length. Bullet leaves barrel following a hot, still expanding gases, creating a muzzle blast. That's why when we fire, we hear the sound. That sound is due to this muzzle blast and the muzzle flash. Okay, and then the projectile comes in the air or in a flight. So, as majority of phenomena studied in forensic physics are included in external ballistics, so let us start and discuss the external ballistics here. In external ballistics, the very first phenomenon that is to be discussed is the muzzle velocity. Muzzle velocity can be defined as the velocity with which a projectile or a bullet comes out from the muzzle end of the barrel. So that's why we call it as muzzle velocity. So there are the certain calculations shown here by which we can calculate the muzzle velocity of the firearm. The muzzle velocity of the firearm and this criteria, the bursting of the firearm can be many of the times reduced uh, by making certain kinds of uh, constructions in the barrel or the nose of the barrel. That's why one might have heard the word silencers. So these silencers slightly change this muzzle blast, the way a muzzle blast takes in the barrel. Okay, and uh, it can affect the sound with which it comes out when the projectile is being fired. As discussed earlier, spinning motion of bullet is due to the lands and grooves in the barrel, in these barrel formations. Now, this spinning motion constitutes many other phenomena, not only just giving the stability to the bullet and higher velocity and higher range to the bullet, but many drawbacks or the other phenomena also occur due to this spinning, like drift of the bullet. Drift of the bullet is when the rifling is right hand rifling. So in that case, the bullet slightly drift towards right hand side. Okay, like the same ways, if the rifling is left hand rifling, the bullet drift towards left hand side. So that is known as the drift of the bullet. Okay. Spinning can also constitute in wind deflection. So if wind is towards the side of the this projectile or bullet, that is the wind is the 90 degree towards this bullet, in that case the bullet may have a deflection which is known as wind deflection. So these are the phenomena which are constituted by the rifling, and there are like various calculations to calculate these wind deflections and make certain changes in the rifling patterns or the pitch of the barrel. Next is the jump or vibration of the firearm. This is also known as recoil of the firearm. Now, recoil of the firearm is basically based on the Newton's third law of motion, where the projectile moves in a forward direction. So there is a force inserted backwards of the firearm. This backward force is the recoil of the firearm, and the firearm jumps from its position. Okay, now recoil is though not very important in firearms, not having many like advantages, but the same thing can be like used as an action mechanism in a pistol. A pistol use the action mechanism of by using this recoil, and uh, it can like reload, extract, eject the firearm. But firing, of course, the firing is done by pulling the trigger itself. So this jump of the firearm is again like can be calculated by the formula given here in this slide. The important aspect of this recoil or jump is that if jump is not that grip is not handled properly, okay, there will be less control on this recoil. Okay, the aiming power or aiming of the firearm can be distorted. So many calculations has to be done. What should be the force, the muzzle velocity of the firearm, so that we can reduce the jump, or certain constructions in the barrel can be made to reduce the jump of the firearm. In exterior ballistics, one of the major aspect is the flight of the projectile in the air or in motion. So basically this flight is known as trajectory of the projectile or bullet. So trajectory is usually parabolic shape, is in parabolic shape, and it obeys or is governed by the laws of the motions, or Newton's law of the motions. Forensically, this is very important to know the angle from which the weapon was fired, the range of projectile has covered, and many other phenomena which occur as or dependent on the trajectory. One of these phenomena is to determine the safe range in a firearm or in a case. Like if you see here from this diagram, if someone is standing in this trajectory, if someone is standing in just middle of this middle range trajectory, okay, and height is less, so the person is likely to escape the injury or escape the bullet. Okay, whereas if someone is standing in front or back of this position, is probably or likely to hit by the bullet. So these ranges, these calculations are very important while when we investigate the things like fire burst in a crowd, okay, or in a mob, where the bullets may hit someone in the crowd, and that time it is very important that what angle was taken by the armed forces to fire, okay, what was the position of the suspect victim, okay. So all these things are very important in such type of investigations. So here are few calculations by which we can calculate or determine the certain important characteristics of the trajectory or the flight. The way in this, the very first is the factors governing the flight of the bullet. So usually the gravity and of course the air resistance will have the effect on the projectile. So in this case, the important is the horizontal range, to determine the horizontal range of the firearm. So that can be determined by these formulas. The vertical range are determined in many cases where we want to determine whether a projectile can reach up to that distance of fire or not. So in that case, vertical range is important. Okay, in maximum horizontal range is important to know whether this gun or projectile is capable to take a shot at a particular distance or not, and what are the conditions and governing conditions in which shot will be taken. As we all, this calculations are very basic calculations of uh, Newton's law of dependent on dynamic motion, so they can be calculated. Next is the wind deflection. As I discussed earlier, the wind deflection is the effect of the wind on the projectile and deflecting it from its path. So that can be calculated. So that depends on the time of flight, muzzle velocities, and the velocities of the wind. In this, in continuation, the next is the canting. As I discussed, when we like drift the gun or the weapon from right side or left side, we can make the bullet to like move towards in that direction. So effect of cant can be a drop and sine alpha. Okay, next is the gyroscopic drift. The That is due to the spinning motion and rifling in the barrel. Velocity of bullet is can be like vertical component, vertical velocity, as well as the horizontal component of the velocity can be calculated by these equations. Next is the let us discuss few phenomena of terminal ballistics. So terminal ballistics, when a projectile hits a target. Okay, so whatever phenomena occurring there are being studied in terminal ballistics. In this, we'll start with few certain things. I'm not going in detail in terminal ballistics. The very first thing is the wounds, the entry wound, how a wound is being made. So here you can see the pathway of the bullet, how bullet is entering in the tissue from outside and entering inside. There are, like in this figure, if you see here, there are certain phenomena that has to be seen. That is because of the elasticity of the tissues or the muscles. If we see here, when a bullet hits, because of elasticity, an angle is made, okay, and bullet enters inside. Then after that, the tissues, the flaps of the tissues come back in its original position. Because of that, the diameter in which a bullet enters in a project in a target gets slightly reduced. So entry wound in any firearm injury is always smaller in diameter than compared to the diameter of the bullet. Now this thing is due to the elasticity of the projectile. Illustrated here is a firearm wound with a muzzle impression. So if a firearm is shot with a contact shot where the muzzle is in contact with the body or the tissue, so there is likely that the imprint of the muzzle is formed on the tissues because of the burning and high temperature of the muzzle end of the barrel. So that is a clear indication that the shot or the firearm was fired in a contact shot with the body. Here is another example of contact shot where the blackening, tattooing or singeing of the tissues can be seen due to this muzzle imprint. Okay. By terminal ballistics or examination of the wounds, we can also determine or we can have an idea of range of firing. Uh, in this the certain characteristics which are produced on the wounds or firearm wounds can help us in this smoke of the firearm, the presence of the smoke, flames, or tattooing on the surrounding of the wounds. So if absence of presence of smoke is there, so presence of smoke indicates that a weapon is fired from 2 to 3 feet distance, or presence of flame is there is an indication that weapon is fired from at least 2 feet. Presence of tattooing is an indication, or it's a, we can say that tattooing is a phenomena where unburnt particles of the propellant charges enters in the tissue or in the skin surface, where it forms an permanent impression on the skin, which cannot be wiped out by wet cloth also. So that's why the term tattooing comes from. Okay, this tattooing is again like weapon is from in a distance of 4 to 5 feet. So tattooing is likely to present. If it is beyond 4 to 5 feet, then no tattooing is seen on the uh, or surrounding the wounds. Okay. And then many of the times we need to test fire the weapons with using the same ammunitions to determine what could be the range of the firing. In this examination of wound or examination of firearm wound can also give us an indication of uh, angle of fire. So here is an illustration where if the projectile hits with a 90-degree angle with the surface of the tissue, so as clear-cut circular hole is formed, whereas if the bullet of projectile hits in a oblique angle with an angle, so that oblique mark or oval injury hole can be seen in the tissues. Broadly, there are two kinds of the comparisons we have to make in ballistics. One is linking the cartridge with the firearm. The second is linking the firearm with the bullet. So whether a particular bullet is fired from this firearm or not, so that is the most important examination that has to be performed. So for this examination, uh, we compare the striation marks present on the bullet. The process is that if a bullet is recovered from a crime scene and a weapon is recovered, we fire a test fired bullet from the recovered weapon and obtain a test fired bullet. So now we have a bullet recovered from the crime scene and another bullet which is test fired from the same firearm which is in question. Now we keep this both the bullets side by side on comparison microscope. It's a special microscope made for this ballistic purposes, which compares the two images side by side, that is in juxtaposition, uh, and helps us in comparison. So if the striations, these lines, coincide with each other, we can say that both the bullets are fired from the same weapon. The principle behind comparison is that these striations are individual to the barrel. So a particular barrel will produce same kinds of striations every time when a bullet is being fired. So one can say that these striations are the fingerprints of the barrel. Okay, so this is the principle which we use for comparison. The same principle is used to compare the cartridge and the firearm. In that case also, we fire a cartridge from the firearm and we obtain the test fired cartridge. So we have a cartridge from the crime scene which is having a firing pin mark at the base of the cartridge or percussion. We have a test fired cartridge which has a firing pin mark which is being fired in controlled conditions. Again, we keep this both the cartridges side by side in comparison microscope. We see the firing marks, we compare the firing marks in juxtaposition and conclude whether both the uh, firearms or the cartridge are fired from same firearm or not. Apart from this, there are many other examinations like determining the range, the propellant used, the examination of the GSR, that is known as the gunshot residues. Okay, many of the times there is a phenomena called ricochet of the bullet, that when a bullet hits a surface, it changes its direction of fire. Okay, so ricochet is one such phenomena which is being studied a lot in forensic physics. So here I have tried to cover the basic outlines of forensic ballistics examinations. Okay, so this was all about in forensic ballistic examinations. Thank you all.